Hey everybody, and welcome back. Today we've got a speaker that's not a new speaker for us. We've seen these in here quite a few times now. This is the VMPS 626R, and I think this is the fourth one that we've upgraded. And we've had to go through each one and design something specific for each one because they've all been different. The drivers have varied in these things for quite some time. The cabinet has remained the same. The planar magnetic mid, which is a pretty good little mid-range driver, has remained the same. There's been a couple of tweeters dropped in and out of it. This is the RM Cantus ribbon tweeter, which was used commonly in some of the later models. This is, and I'm going to quote the part number to you, this is the G2SI. It's one of the less expensive ribbon tweeters, and these are still commonly available and can be purchased through distributors. So I'm going to put this back over the front of it to protect it. These are actually pretty fragile. If you blow on them, the ribbon will get all out of control in there, and it'll stretch it out. So you have to be real careful. Don't let the wind blow it, or don't let air blow on it. You don't want to vacuum over the front of them or anything like that. So, like I said, these things have varied a lot, and I'm going to go through some of the history on this model and look at early versions that I've upgraded. And we reached a point this time where I felt like I need to design an upgrade that fixes all of them, because there were significant problems with these things, and we'll get into that in a few minutes. But I wanted a fix all for all of them. So we've came up with a good solution. And before we get into the history and what I've done with this model and stuff, let's look at what came in this particular one. And this one came with a actual grill, unlike some of the other models that had what was called a wave guide, which wasn't a wave guide at all. It was just a wooden panel across the front, and there were some things done to it in efforts to solve a problem with these speakers, but it didn't solve the problem. The cabinets in this particular one are pretty well made, and it's a beautiful gloss finish. Looks really nice. So no complaints there at all. Now, the crossover on these things, whew, man. This was a plate that was glued in on the back of this thing. I'm going to spin it around so you can see the back. And there's just a hole here in the back, and this plate was just glued in from the back side. And when I pressed on it a little bit, the whole thing just fell out. So this glue that they used, or silicone that they used, dried up, and it wasn't even really holding it in place. The binding posts are just some big brass binding posts, and the crossover is literally just soldered to these things. Like there's a big glob of solder on the ends of these things, and there's just some cheesy wire dabbed onto it. It's a mess. The other thing that we see commonly with this brand was the owner wanted to match all the capacitors, which is great. We do that as well. We'll measure several hundred Sonocaps, and we'll have them there, and when orders come in, we'll cherry pick them, and we'll pick values that are exactly the same or within a really tight tolerance. What he did was he was using these cheap Parts Express caps, the little Dayton caps, and to make up for the fact that there was such variance, he would put what was called trim caps on there, which is a bypass cap, to try and get the value up to a certain value. Well, when you do that, the dissipation is completely different from one speaker to the next, and literally we would see different values on one speaker versus the other. There may not be a trim cap on one, and then there was on the other. And when you take a smaller cap that has a very fast dissipation rate and you bypass it over a big one, it helps discharge some of the stored energy in the larger cap, and it sounds cleaner and faster. But when the speakers are completely different and there's different bypass caps on each one, it sounds different despite the fact that the cap values were made the same. Not a great idea. And this one has an ERSI Super Q on the woofer circuit. Now the Super Q woofer, or the Super Q coil, was one of the best laminated I-cores out there. And we use a lot of these in versions like it now from US Coils. And they're ideal for low frequency ranges. But you don't want to use a cord inductor right up through the mid-range, it can cause some smearing in the mid-range. There were some air core inductors that I think came from Matasound that were on the mid and tweeter circuit, but it was always first order filters, because I don't think he really understood how to design filters. And the name, of course, being VMPS, stood for something minimal phase speaker. And sometimes, because they're using first order slopes, the drivers would be out of phase. In other words, the polarity needed to be flipped on a woofer, and because it wasn't, there would be a huge hole there. And I think later he figured out that if you flip the polarity, at least they would be acoustically in phase. But the response was typically all over the place. The other problem with these things was he tried to play these planar magnetic drivers, which could play up pretty high. They could play up to nearly 10K. He would play them to 10K and then just put a small cap on the tweeter and cross it way up there to high frequency. Well, when you cross things at a high frequency, those wavelengths are really short. So as you move up or down, the time alignment of the drivers changes, and because those wavelengths are real short, they'll be out of phase from each other, and they'll cause huge holes in the response. As you move up or down, the response can change as much as 20 or 25 dB, depending on where the drivers are in phase or out of phase. So it's a total mess. The other thing was, and this was common to these designs, when you run a driver like this all the way up to 10K, notice it's about 3 inches across as far as the playing surface on it. So as you get into the higher frequency ranges, like above 7 or 8 kHz, they start to beam. So they don't have as wide a dispersion as, say, a tweeter that has an element that's, 3/8 of an inch wide or 1/4 of an inch wide versus this thing. So if they would have just pushed the crossover point down lower, then the horizontal off-axis would have been great. It would have had even coverage. But because these were allowed to play up so high, they began to beam. So the solutions that he came up with was to try and block off the sides to make it a narrower playing surface, and then it wouldn't beam. So there were these pieces that were glued onto the sides here of this mid-range driver, and it minimized the width of it right through the middle and allowed it to image a little bit better to the left and to the right. Later versions of this model, he put a big piece of wood over the front, and the piece of wood just had a little slit down the middle that the tweeter and the mid would play through, so that the mid, only being this wide, playing through that surface, would have better off-axis response and it wouldn't beam. Unfortunately, that came with a whole lot of other problems, including a bad cavity resonance between the wood wave guide, which is just a big wood baffle, and this surface. It was a total disaster. So, and then what would happen would be they would put these pots on the back of the speaker to adjust the tweeter in mid levels to try and compensate for the output levels being completely different and balance it out. And he could swap out different woofers. The sensitivity of the woofers may vary quite a bit, but then it was just back to using the pots to try and bring the level of the tweeter in the mid down a little bit to match it. But it was riddled with problems. And those problems started pretty early on, and we're going to take a look at it. We're going to kind of go back in time. We're going to look at this model and all the different variations that we worked on. Let's first start with, and before I get too much further into it, I told you use different woofers in these things all the time. This is the woofer in this one. The woofers never fit in the holes, ever. There's always a big gap. He used a great big hole, and then he could just put different woofers in there. I don't know if you can see in the video here, but this woofer likes a lot filling that hole, and there's a big gap all the way around. And there was always a big gap all the way around. And this one may be the one they called a mega woofer. What happened would be they would increase the gap around the voice coil to drop field strength. And then you'd have to put a great big magnet on it to bring the field strength back up. And of course, stamped steel frame. I hate those things. Little carbon fiber cone, that was kind of nice, and then you got that big cork surround going all the way around it. We tend to take a different approach. Like with our woofers, you notice it doesn't have a great big motor structure on the back. There's no big magnet, but the moving mass is a lot lighter, and the gap around the voice coil is tightened up to a high tolerance, so that most of the field strength is focused in the gap much more. It's much more focused versus with some of the woofers you see like that with a great big motor structure. The gap is actually really large and it's not very well focused. So don't think just because you see a big magnet that means it's got a better motor structure. It's better in some way. That's not the case. So let's go back in time here to 2007. It's when I got the first 626R sent to me. And let's take a look at the pictures that I took of these things. And it's a different woofer. That particular woofer was a little bit bigger in diameter and it had a wood phase plug in the middle of it. And as you can see in the picture, there's a pencil sticking between the woofer and the through hole for it, showing that there's a gap big enough you can stand a pencil up in. And then soldering everything to the drivers. There's push-on connectors, but the wiring is soldered onto the push-on connectors, and there's just bare copper wire exposed, which it's going to oxidize over time. It's all that stuff is just left like that. That's just the way it was assembled. And I've got another picture of it here where you can see the inside of the speaker, and this particular model was white. And there was an upgrade you could add when you ordered those things called Sound Coat. You could add Sound Coat, which is, I don't know, 150 extra bucks. What Sound Coat was just drywall mud and some white paint. They just mix up a little slurry of that stuff and reach in with the paintbrush and they just slop that stuff all around on the inside and call it Sound Coat. And that was 150 bucks extra for $2 worth of drywall mud. It did zero. Trust me, it did absolutely nothing. So let's take a look at the measurements on that one that I measured back in 2007. I was able to adjust the pots and get a reasonable response out of both speakers. And if you look at it, you think, well, that's not too bad. I mean, there's a little bit of a hump at 800 hertz or so, and it's a little choppy, but overall, we're within plus or minus 3 dB, right? Yeah, well, within an industry standard. But look what happened when I moved the microphone 2 inches. Take a look. I just moved it at a meter away, 2 inches. Notice how big the response completely changed. That's because the crossover point from the tweeter to the mid was so high in frequency that any little change in time alignment made them out of phase. And then if you look at the vertical off-axis, where I actually started moving up 4 inches at a time, you'll notice that the vertical off-axis just goes everywhere. And also, you probably note, these measurements don't look like the ones that I've been posting because these were done back in 2007. That was an older version of Clio that I was using, and it didn't allow me to print graphs off with colored lines and stuff. They were just all black. Also, the spectral decay I had on that one, you can see there was a little bit of a ringing and stored energy there. Overall, it was a mess. And we went back through that thing and designed a crossover that flattened it all out, pushed the tweeter crossover down much lower, balanced everything out, and it worked out just fine. And then I got sent another one. This one was in 2013. And we'll take a look at this picture, and you'll see that it has what he called the waveguide on it was just a grill that snapped on that was all MDF, and it played through a little slit. And again, you can see in another picture here that the woofer, once you pulled that grill off of there, the woofer didn't fit the hole again, and that woofer looks different than this woofer, and it looks different than the woofer that was in the first one. And there's another picture here of the crossover. You can look in and see how that thing is wired. It looks like a rat's nest in there. Also, I took a picture of the tweeter. The tweeters never fit in the holes at all. This one was the same way. The tweeter was recessed in really deep. The one that came to me back in 2013 also, it was recessed too deep. So there was edge diffraction from the tweeter being over 1/8 of an inch too far down in the hole, maybe a little more than 1/8 of an inch. And I took a picture of the back of it. It's just exactly like this one here that you see. That wood panel is just glued on from the inside, and not real pretty. Not real pretty. So that was the one in 2013. So let's look and see what happened when you put that big wooden panel on there and kind of get an idea of where it went and why it was done. This is the new on-axis response, or I shouldn't say the new, I should say the on-axis response of that speaker that you just saw a picture of with that big wooden baffle on it and playing through that little slit. made the response a disaster. And if the manufacturer would have ever measured these and had any idea how they measured, maybe they would have gone a different direction. I know that their speakers were never measured. It was never designed by measurements. It was designed by ear and by adjusting the pots and just putting first order filters on everything. Also, if you look at the spectral decay on this thing, which again is a disaster, you can see there was quite a bit of ringing, and there was, in particular, right there where there was a big peak in the mid-range, there was a ring right there that you could audibly hear. That was a resonance that was going on between that wood baffle and this front of the baffle of the speaker. It was rough. And then on that one that came in, I tried to adjust the controls to try and balance it out, thinking maybe I can turn the mid down or up and try and fix it. There's what happened when I started adjusting the controls. It didn't fix the response problems. And then let's look at the horizontal off axis with that big waveguide on it. You can see that it did minimize the playing surface on it, and it allowed the off axis to drop off pretty evenly, as far as there wasn't any big beaming going on or anything, because it was having to play through such a small surface. But as you can see, the frequency response is still a complete disaster. In fact, let me look at the sensitivity. It dipped as low as 72, 73 dB and peaked at the tweeter end at nearly 90, and it averaged probably 79 all the way across if you was to draw a line through it as an average. So it was bad. So next, let's look at the vertical off axis. And this was what I was talking about. Whenever you have a speaker like that where you're crossing at really high frequency from the tweeter to the mid, as you start moving up, it completely falls apart. Look at the graph there, and you can see the red line was the on axis, and then the orange line was just moving up 4 inches. The yellow line 4 inches again, and then 4 inches again the green line. You can see how the response just goes all over the place. So next, the thing I did on that model was just took that waveguide off, just took the front baffle off. And this is the difference with it on versus with it off. You can see with it off, it had a little broader range there across the mid. The tweeter still was a little out of whack, but it had a smoother response, and it got rid of some of the resonances that were going on in between those two baffles. So I was able to get this response. Let's look at the response on it. And I remember looking at that thinking, man, that's just, the sensitivity is just so low on this. There's got to be something wrong. Like maybe my amplifier settings are off. It shows 1 watt, but it's averaging less than 80 dB then, and that's just unusable. So I just grabbed one of our speakers off the shelf, one of the N1s, which was a speaker we had with a little M130 and the BG planar magnetic, and I just threw it up on the stand and shot a response on it, and just to see if things were off or not. And you can see the measurement there. Our speaker measured nice and smooth all the way across. The VMPS really was that low in sensitivity, so I thought, okay, it really is that low in sensitivity. So then I looked at the vertical off axis and the horizontal off axis. Now, looking at the horizontal off axis with that big panel off, you can see that we got into the beaming frequency of this thing, and it did drop off right around 7 kHz or so. It's centered there where you can see the off axis response begin to beam. That was supposedly solved by that great big baffle that was stuck on there, but it didn't. I mean, it may have solved that problem, but it caused a whole lot of other problems. It was still a complete disaster. Vertical off axis, again, as you start moving up and down, it was cancellation going on everywhere. So that thing was a mess. That was 2013. Next, I had one show up in 2018. And this particular pair had tweeters that were not working. So let's look at the frequency response of this thing the way it came in. And it also had that big baffle across the front of it and the slit that it played through. And it's a mess. There's the on-axis response. And I thought, okay, let's just look at the mid by itself. Let's just see what we got here. So here's a measurement of the mid with and without that big front baffle on it. And as you can see, there's a huge hole in the response there when you stick that baffle on there with the little narrow slit through the middle of it. And looking at the spectral decays, you can see the resonance that it caused. You can see the difference with that baffle on and with the baffle off. With it off, obviously, it's a much smoother, more balanced output. So it was obvious at that point that it would be best to design something for it without that front baffle. That front baffle just needed to be discarded. Now we get to this one. This one was in 2024. This is just a few weeks ago. This one came in. And I want to first show you the measurement of it from the way the settings were when it came in the door. And yeah, that's as rough as I've ever seen. So I don't know if they were being listened to that way or not, but that's where it was set. So Hobbs got to work on this thing, and he started adjusting the potentiometers and moving the microphone up and down and trying to find a spot somewhere where everything is in phase. And he managed to find a spot that was pretty close to the tweeter axis, and it's pretty smooth all the way across. As far as an average, it's still choppy, and the response still averages 80 dB. But this is very deceiving. You think, okay, on-axis response looks really good. Okay, hold that thought. Let's look at a couple other measurements. Let's look at the grill effect. Now, the grill was a regular grill. This one didn't have that big waveguide thing on it, so it had rough edges on the inside edge. They didn't round those so that they would minimize diffraction. So there's diffraction. So you can see the difference in the effect of the grill, which is not as bad as I thought it would be, but it's still a little rough. And then let's look at the spectral decay. You can see that there's still a lot of residual traces going out there where there's some ringing going on. Let's look at the horizontal off-axis, and remember, this is with this mid, with this stuff glued onto it, and we had to work hard to get this glue off of there. That was with this on there to minimize the cancellation or minimize the beaming in the horizontal plane. So let's take a look at the horizontal off-axis, and it looks okay. Looks pretty good. But now let's look at the vertical. Now we're going to look at two vertical off-axis, one going up and one going down. And I want you to pay close attention to just what happens to the response. Keep in mind now, we got it to look really smooth, and it was pretty close to tweeter axis. Got it balanced. Okay, we're in phase, and we've adjusted the levels, and we look okay. Now, look at the measurement here, the vertical going up. The red line is that on axis. We went up 4 inches. Look at the orange line. Look how it completely fell apart. And that's just moving up just a little. And then the yellow and the green, you can see it completely cancels out. There's holes in the response. Think about what that's doing to the total in-room response and how your power response or in-room response is going to be completely all over the place too, because it's not a consistent response in all directions. It's got hot spots and holes, and it's a mess. And then let's look at the vertical going down. So we're starting out the same spot, and we're moving down 4 inches at a time at a meter. It gets even worse there, and in fact, at that point, the mid and the woofer, as you start moving down, those become out of phase, and there's huge hole down at the bottom of it. So it's I can't believe they were ever made this way, but they were. And so I said, you know what? And it averaged 80 dB sensitivity, which is, again, to me, that's almost unusable. I thought we've got to come up with a solution. Let's be able to fix all of these models that are out there. So I had Hobbs go to work over there and 3D print a little adapter ring, and it fits right in the holes of all these speakers. So all of them, they all have the same cutout. We can put this adapter ring on there, and then we can put a good woofer in there. Put our M165 in there that's in the Encore, and this thing sounds phenomenal. It's a beautiful sounding woofer. It's very well controlled. It doesn't take a lot of parts. And then once we've got that on there, we had to clean the mid off, and this is a great mid. And then we put a bunch of gasket material under the tweeter and pulled the tweeter out so that it was flush. And then I was able to go and design a new crossover for this thing. And much like all the crossovers I've designed for in the past, I've put the drivers within their own ranges so that they stay within the band pass that they need to be in, so that the off axis in every direction would be consistent. And it worked just like it has before. But at this point, with this woofer, it not only worked, but the sensitivity came up to 89 dB sensitivity. So now we got a usable range of sensitivity for this thing. So let's look at the new on-axis frequency response. And yes, it really is that smooth. And it's not just that smooth at one point in space either. But first, let's look at the crossover response. You can see that we let the tweeter play on down to a little above 2,000 hertz, about 2,200 hertz. It's got a third order filter on there, so we're controlling it just fine. No worries about that. We've used those tweeters a lot. We've used them in designs that we've offered way back in the past. So it was nothing new for us. I knew how to work with that tweeter. The mid is now within its own range, and it's got roll off on each end. And then the M165 woofer down at the bottom, creating a nice smooth sum. Now let's look at the horizontal off axis, and you can see it drops off really well. It's very balanced all the way across. There's no beaming. And then let's look at the vertical off axis. Now we're on tweeter axis, and we're going up, again, 4 inches per measurement. And you notice, because the drivers are crossed at a much lower crossover point, we're not changing the time arrival as much at the crossover point. Sure, the time arrival is changing, but they're crossing in a range where the wavelengths are longer. The wavelengths where these are crossing are a little over 6 inches long versus the wavelengths where they were crossing before were about 1.5 inches long. So when you have a wavelength that much longer, when you move 4 inches up, the phase rotation is maybe 3 or 4 degrees, maybe 5 degrees of phase rotation, whereas before at the crossover point, it was 80 degrees of phase rotation or something. So we're consistent now over a wide range. Spectral decay, nice and clean. There's a few little spots there, but overall, 10 times cleaner than it was. The impedance is nice and balanced. Let's take a look at the impedance curve. And it does drop to 3.6 ohms at the very top up there where the mid is crossing. But, nothing bad. So overall, we made something out of this thing that will work for all of them. And we're also going to 3D print a new plate for the back. And you'll be able to put this plate over the outside, and it'll inset within this hole. And you'll have to drill a few little holes there for the screws to screw that plate on there. And we're going to make it fairly thick so it won't resonate. And that will fix this problem. You won't have to glue something in from the inside or try and screw something in from the inside. And then these holes here where these pot were sticking through, you're just going to need to chase those just a little bit with a little bigger drill bit, and it's perfect for the tube connectors to drop right in there. So what we've come up with will work with all of them. All of them have this same mid driver, and even if you have the earlier spherical planar tweeter, you can pick up these tweeters pretty commonly. The dealers that are RM Cantus dealers sell these. They're still available, and you can order this upgrade kit, and you can turn that speaker into a nice speaker. I want to address a couple other things real quick before we go, though. This company had other models that were heavily sold back at that time. There was what was called an RM30 and an RM40, and then some really big model. I don't even remember what it was called, but I've been asked a lot, can I fix those? Can you upgrade these? Can you fix my phase problems? And to be honest, I can't. The RM30 had woofers mounted on a wedge-shaped panel at the very bottom of the speaker. But basically, the vocals were coming off the floor. And then it had a line of these and a tweeter at the top. So the acoustic centers were so far away, there's no fixing it. The best thing you can do is pull these panels out and use them in something else. These panels are kind of fairly well sought after because they're not commonly available anymore. And there are a lot of different designs you can do with these things. And you can match them. You can match them with our woofers and a tweeter of some kind, like the design right here. There's a lot that can be done with these things. These were even used in car audio. They were used in the monsoon panels that were desktop speakers, a little open baffle. You got something you can work with here. The rest of that stuff, I can't fix it. Same with the RM40. The RM40, I think, had a woofer at each end. It had a whole line of these and a little tweeter in the middle. It wasn't as bad. The acoustic centers are still so far apart on that, with that RM40, that there's still really no fixing it. There's really not much I can do with those models. And then the biggest one had some big woofer at the bottom. It had a whole line of these things and a tweeter about 5.5 or 6 feet up in the air. I can't fix that. And I've heard that speaker. It sounds like the highs are coming from way up top. Everything seems disjointed. Again, pull the panels out of it. Put a little planar magnetic tweeter with this thing, and then you can do, there's a lot of things you can do below it when you've got something that'll play down to, 400 or 500 hertz pretty easily. So I'm sorry for all you guys who have those other models. I can't fix those models. But for all of you that had these, and there was a lot of them thrown out there, I felt like at the time it was kind of a gateway speaker. It got a lot of people into what they thought was high-end audio, and then they kind of realized it wasn't. But it moved them into the market, and then it moved them up to other models. So a lot of these has just been sitting around because the sensitivity was so low and the response was all over the place and things like that. So if you've got them sitting around and you think, hey, let's turn these things into something. Let's do a fun project with high quality parts. And we're going to have some really good quality parts compared to what was in there. And you'll be able to put something together that is actually a great sounding speaker when you're done. So that's it for this one. I know it was a little bit long, and I thank you for sticking with me on it, but I felt like we had to go through the history of this thing just a little bit to get some perspective and to understand why we decided to ditch the old woofer and put a good woofer in there and make something that will work with all of them. Anyway, thanks again. If you haven't hit the subscribe button, please subscribe. Hit the like button so we'll get all the views and all that good stuff. And thank you for watching. See you in the next video.